Okay, I think I better put this on a different width here. Let me just change this for a second. Let's go page width. There we go. Okay, hello everybody. It's Friday, and I know you guys are probably about as interested in learning stuff as a kick in the teeth. But we're going to do these anyway. I'm going to get your substitute teacher, Miss Lauren, to Miss Folland, to show you all these questions here, and hopefully we'll be able to understand them. Expectations for assessment is just follow along. If I ask you stuff about the questions, I just want you to be able to kind of understand how it works. So this particular shape here, if I asked you to calculate the surface area of this shape, it kind of relates to what we were talking yesterday with the cubolinks. Remember when we took that one cubolink off and I said, does the surface area of this increase or decrease or stay the same? And it was staying the same. But then when I took a whole row of it off, it actually decreased the surface area. So if you think of this stairs, these steps, as those cubolinks, we can see that it's kind of like the second example, that this whole part right here is missing, right? It's like these cubolinks that used to exist in that area right there, if we think of them as cubolinks, are no longer there. So how are we going to calculate the surface area of this? Well, I do know that if I put a 1 on this rectangle right here, and I call this rectangle right here number 1, and then this top step here, I'll call it number 2, okay? If I call that 1 and 2, just like yesterday what we were talking about, is the 1 plus a 2. Whatever 1 is, we don't know what it is. Whatever 2 is, we don't really know what it is. But those two together will equal whatever the area of the bottom is. And if I look at this step, I know the bottom is actually a rectangle, and I actually know that it's a 90 by 80 rectangle, which is 7,200 centimeters squared for the bottom. Okay, that's the area of the bottom. Now, since the bottom is that, then whatever 1 is, which doesn't really matter, and 2, we know that that is also 7,200 centimeters squared. Centimeters, sorry, Bryn. That's a meters, just in case. Centimeters squared. So the 1 and the 2, and we'll call the bottom 3 if you want. So I'll just organize it here in a table. Okay, I'll go number, and I'll go dimensions. So if you're taking notes right now, just write this chart down, and we'll just kind of work through this together, and we'll do the area. Okay, and we'll put 1, and we'll put 2, and we'll put 3, and we'll label at the bottom just to kind of give us an idea. So the bottom, the dimensions are 90 by 80, which is an area of 7,200. And don't really care. I could figure it out if I wanted to. I don't care. But I know together, those two are going to equal 7,200 centimeters as well. So don't care what 1 is. Don't care what 2 is. I could calculate it. It's actually, 2 is actually, if I wrote it down, would be, I think, 60 by 80, which would be 4,800 if I wanted to calculate it. And 1, if this is 90 and this is 60, this would be 30, correct? If I write 30 right there, that's 30 by 80. So it would be 80 by 30, which is 2,400. And if I added those together, 4,800 plus 2,400, I would also get 7,200. So we know it works. It does work, okay? So that's the 1 and the 2. And then if I think of the front here, so I'm going to call this, I'll use a red marker so you can see it better. I'll call this one 4 and 5, and I'll call the back of this, the back that we can't see, the very back behind that's kind of leaning up against the the diving board, we'll call that 6. So I'll label it over here. I'll go 4, 5, and 6. Okay. Now, of those shapes, the one that I can figure out very easily is that backside, because that backside is a rectangle, and even though I can't see it, we have to be able to visualize the length of that back would be 80, and the height of that back, or the width of that back, would be 40. So that back one, which we'll call number 6, and we'll write down back there just so we can have it written, will be 80 by, did I say 60? No, it's 80 by, I think I made a mistake. It's 10, isn't it? Oh, 40, there it is. 80 by 40, which is 3,200. Now, what does that mean? That means that 4 plus 5, I know for a fact, since they're composite sides, will equal that backside, which is 6, right? Which we know to be 80 by 40, which is 3,200. Okay. Now, if that's true, let's see if we can figure out what the dimensions are. If this whole height is 40, this whole height is 40, and this is 20, then this is also 20, because 20 and 20 make us 40. So this is 20 and 20, because the whole height is 40, and I'll erase that red line because you can't see the 40, but it's there. So this would be 80 by 20, and this would also be 80 by 20. So I'm going to write that in, 80 and 20, 80 and 20. But we didn't need to know that because each of those is 1,600, right? But we knew that anyway, right? So here, I didn't need to calculate it. It's 3,200. And yes, Bryn, that is a 6. That is a 6. It's 1600. 80 times 20 is 1600. I better change that. There we go. 1600. And then the only one we have to calculate left is this weird one. I'm going to erase all the stuff again. This weird shape right here. And I'm going to just kind of transpose that into a side here. If I looked at it, it would be like that. That's what it would look like. Okay. Now there are multiple ways we can do this. One way we can do it is to cut an imaginary line here, and we can call this 7, and we can call this 8 if we wanted to, right? And we can calculate 7 and 8 if we wanted to separately, as long as we know the dimensions. Let's see if we know that. Well, the whole thing is 90, right? If I look here, that whole dimension there is 90, and that whole dimension here is 40, right? So I have that. I could do that. But do I have enough information here? I know this is 60 here, right? Because it says so right here. And I do know that if the whole thing is 90 and this is 60, then this part right here must be, somebody? That's right, 30. Well done. So I'm going to put 30 right here. And that would be enough information for me to calculate it, I think, so far. Oh, no, not right here. And 20. Right? That would be 20, I think, because it's right here. There it is there. 20. Okay. So I do have enough. 7 would be 30 by 20. 8 would be 60 by 40, which would be, what do we got here? We got 600, and we got 2,400. But don't forget that 7 and 8 also exists on the other side. So technically, I should put a 9 and a 10 up, right? Even though I can't see it, the 9 and the 10 would be the 30 by 20 again. And it would be the 60 by 40. And we'd have 600 here, and we'd have 2,400 here. Okay. So all of those measurements would be ways we could calculate. Now, if we wanted to get the surface area of the steps, okay? I say, what is the surface area of the steps? Now, the assumption would be, are there any sides that don't factor in to the surface area? So if you take it literally and just said those stairs are transportable and you can pick them up and move them around and shift them around and put them upside down and sideways, if we take it literally, then the one side that wouldn't really factor into, let's say we're painting the stairs, the one part we wouldn't have to paint would be this one. So if I was saying I'm going to paint the stairs, what would the surface area be? An assumption would be I would have to eliminate that bottom because I'm not going to paint it. And then some people might say that the back isn't going to be painted too. So you might say maybe this one's not going to be painted. Oh, I hear growling, so maybe that is going to be painted. I think it probably does need to be painted. So if I was being asked the question, what would you have to paint for this one? The answer to that question is you would have to paint those and just add them up. So you take 7,200 plus 3,200 plus 3,200 plus 600 plus 2,400 plus 600 plus 2,400. That would be what you have to paint. And if you do the mental math on that, those two make 3,000. Those two make 3,000. So up to 6,000, 6,000, 9,000, 12,000, 19,000, 19,600 centimeters squared would be the paintable area of those steps if I asked you that. And the way we do that is we make this table. We then calculate all the dimensions, which is the easiest way to do it. We factor in, the hardest part would be this red little composite side that we drew over here that looked like this, figuring out the measurements of that, and figuring out we can either cut it this way, or we can cut it that way. Or another way that we didn't even talk about would be calculated as a whole square, and instead of adding, just subtract. So if I said this was the whole square, let's make it the whole square here like this. Take away this chunk here would be this chunk. We could have done it that way as well, but that's confusing and it's beating a dead horse, so we'll just ignore that. Okay? But that would be another way to do it. So that's that question in a nutshell. If you have to press pause, Bryn needs some more time to copy this down, or just copy it down in your notes. The video will be posted, so it's okay as well. Okay. This question is fairly tricky, but if it was given to you on the provincial exam, it's not as hard as you would think. Let's say the question was, you want to paint this shelf, okay? What would you have to paint? What would you not have to paint? Okay. So a lot of different parts are going to be important. What am I actually going to paint? So I'm going to take my red marker. I'm going to take my green marker because it's brighter than me. And I'm going to put numbers into things I want to paint. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to just say, maybe these ones here at the front too. That's kind of a tricky one. I don't even know if I need to figure that out, do I? Let's go, okay, 9, 10, 11, 12. And I guess down here that you can't see this number 5 here, this little side here, there'd be one more of those, I suppose, down here. So I should actually make that a 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll just make it a 13. So the 13 would be one of these sides here that would exist underneath that last shelf, okay? So this is a tricky question, but just bear with me. Just listen and just copy things down if you want to, just to see how I do this, okay? So, actually more. I got a 14 here, and I got a 15 here. Those 2 trims have to be painted as well. Okay, let's see if we can do this. So let's start with number 1. So I'm going to make my table like this. I'm going to put this line down here. I'm going to put 1. I'm going to put dimensions. Oh, sorry. What number, dimensions, and area. Just like that. And I'll put 1 here. Okay. So let's look at 1. 1 is going to be this width here, which is going to be the same as this width here. All those widths are 22. All those green lines I just drawn are 22. So rectangle number 1 will be 140 by 22, which if I grab my calculator, will be 140 times 22. The answer will be 3,080. Okay, does that make sense? 3,080. And I'm going to call it, actually, I'm going to call it another 1 because we have one more of those. It's on this side here that I didn't label. It's also 140 by 22. We'll call it 1A, 1B, I guess, or 1B, and that's going to bother some people. Reverse it if you want, just like that. So we got the 2 sides, the 1 and the other side of the 1. We'll call it 1A and 1B, something like that. Okay. Then we got the top, which is 2. We're going to paint that, which is going to be 22 by 115. So 115 by 22, which if we work that out, 115 by 22 is 2,530. There's one more there. Now remember, we're not painting the bottom of it because we're not going to paint the bottom of the board, so we're not going to have a 2B. It's just the top. That's all we have. Now this is where it gets interesting. This dimension here, I mean from the shelf to the next shelf, that dimension there is not labeled. We don't have any labels for that. All we know is that the trim is 2 centimeters. So we know that if I was to kind of make this line here, this line right here, we know that, and I'll use a different color. We know that this is 2 centimeters. We know that this is 2 centimeters. We know that this is 2 centimeters. We know this is 2 centimeters. Okay? And the rest of it is going to be that. So here's the interesting question. If the shelves are all equally spaced, what is the dimension of number 3? I'll give you some time to think about it. All right, we can press pause here for a second. Actually, this would be a good time to press pause. And I want to know what is the length and the width of number 3 for my dimensions. Press pause. Okay, we're back. So number 3, I'm going to write 3. And I'm going to then say if the whole part here, and I'll do another blue line, is 140, because it's right here, then the 140 take away 8 is going to be 132 remaining centimeters. That will be these blue lines right those 4 blue lines, right? Those 4 blue lines will be the residual of 132 because I have to take away the trim, and I end up with 132. Now, if they're equally spaced, if I take that 132 and divide it by the 4 parts, the 3, the 4, the 5, and I guess the 13, the remaining of the 132 divided by 4, if I take my calculator, should be 32 divided by 4 equals 33. That means this is 33, this is 33, this is 33, this is 33, this is 2, this is 2, this is 2, this is 2. Altogether, 33 plus 2 plus 33 plus 2 plus 33 plus 2 plus 33 plus 2 equals 140. And therefore, that is dimension. So number 3, the answer is, what is the dimension of 3? It is not 115. 115 is from this edge to this edge, right? Oh, it is 115. No, it's not 115 because we're going to miss 2 centimeters here, and we're going to miss 2 centimeters here. So actually, this is the weird part. It's actually 115 take away 4, which is 111 because that back is missing a 2 here and a 2 here, so it's 111. And the height we already calculated to be 33. Weird, eh? Which is going to be, oh, I don't even know what that is. Can I do that in my head? 3663. How many of those do we have? We have 4, which is 3663. We got 5, which is 3663. And we have 13. I know it's a weird number. Just bear with me. That's not a B, Bryn. That is a 13, which is 3663. Okay. Wow, there's a lot of organizing for this stuff. Okay, so we got our 1, we got our 2, we got our 3, we got our 4, we got our 13, and then we have, where's our 6? Our 6 is here. Okay, there's our 6. So our 6 is going to be, we already said that the interior of that has to be 115 less 4. So my number 6 is going to be 111 times 30. No, not times 33. What's the width here? Oh, that's right here. That's 22. So this is 22. 22. Yep. 22. 22. 22. 22. 22. I think it's 22. Does that make sense? Is it 22 or is it less than that? Is it 20? Let's just pretend it's 22. Who knows? We'll pretend it's 22. I don't think you lost anything. Did you lose anything? If right now what I would be doing is I was thinking, I would go, Mike, did I lose anything on that, or is it 20 or is it 22? Is this back part right here, where this corner is, to the to the back of it? Is this thickness right here? Is that anything there? I don't think it is. I don't think it is. So we'll go 111 times 22 equals 2442. Okay, that's going to be number 6, which is also going to be number 7 and also number 8 because we have 3 shelves. So we're going to go 7 and 8. We got the same. 2, 4, 4, 2, 2, 4, 4, 2. Now we're not going to paint the bottom sides of these shelves. Those are unnecessary. And I think now the only thing I have to figure out is the 9, the 10, the 11, and the 12, which is these trims here. That trim right there. If I think about the width, that's 2 centimeters by 115. So I'll put a 9 here. We're going to get a space. It's going to be 2 by 115, which is 230. And how many of those do I have? I have 1, 2, 3, 4. So I would have those. And then the only other ones we have to do is this one here, all the way up, and this one here. So 13 and 14, which 13 and 14 would be 140 centimeters tall by 2 centimeters wide. So it's going to be 140 by 2, which is 280, and 140 times 2, which is 280. Wow, that's a lot of work. Let's go full page here so we can see it all. Okay. So when we do the whole thing, I think I accounted for all sides that have to be painted, right? We're not painting the bottom of the feet. We're not painting underneath the boards. We're not painting where the board meets the wall right here. We're not painting where the shelf meets the actual side shelf. And if we think about what is the paintable area that we're going to do, it's all of those. We can add them all up. Let's see if I can do this. No, I can't do this. I don't even want to do this. I don't even care. If you added all these up, that would be the total paintable surface area. Oh, the one thing we have to factor in is, the other thing that maybe somebody said that's bright, are we painting the back of this sucker? Very good question. You know what? I think we do. I think we do. I think we have to paint this. So we're going to call it face 15. I'm going to put face 15 there. So I think, what is face 15? It is the back side, which should be 140 by 115, which is going to be a freaking big number. 140 times 115, 16,100. 16,001. Oh, sorry, Brent. 16,100. And then if you added those all together, that is the paintable surface for the shelf. Okay, this was your homework questions. This is question number, well, it's no number. It just says, what is the surface area of this? Okay. So for this one, we need to start kind of labeling on our picture how many faces we have. I'll just draw right on it. I like this blue marker. I think I'll use it. I have a 1. Are there any other 1s on there? Yes, there is. We'll call it dimensions. By the way, Bryn, dime means dimensions. Area means surface area. So 1. I should have probably made the area thing bigger. So we got number 1. And we know its matching partner in crime will be the backside that I can't see. We'll call that 2. So what is the dimensions of 1? It is 6 by 5. Or 6 by 5. There we go. By the way, tell you what, Lauren, I'm pretty sure these guys didn't do this question for homework. Their track record with actually doing homework is 0. If you went around and actually asked them to show their homework, I bet you most of them wouldn't have it done. A few would, for sure, but not everybody. So press pause. Let's see if they can figure this out. Let them finish this chart. See if they can do this on their own. Okay, we're back. We have 1, which is going to be 30. That's the front square. And then the back square, which we can't see but exists if we're going to paint it, is 30. We're going to assume we're painting this house. Let's go with the triangle as being 3. Do I have enough information in this triangle to calculate its area? Remember, area is base times height divided by 2. Or 6 times 4 divided by 2. Or 24 divided by 2. The area of that triangle is 12. Okay? So if I wanted to put that in, I could just basically drag this sucker up right in there. We'll shrink it a little bit. There it is. There's the dimensions. 6 by 4 divided by 2, that's 3. And we have another triangle on the other side, which is the same dimensions. So we have 12 here and 12 there. Done. We're then going to put a 5 in here. Oh, by the way, I better put my 4 back here just to say it's there. Okay, 5 is a rectangle. Even though it looks like a parallelogram, if I rotated the building, you would see that that roof is actually a rectangle. Do I do both measurements? Yes, I do. I do know that 5 is 10 by 5. It is 10 by 5, rectangle, which is 50. And the other side of the roof, which I can't see, is 6. It is also 50. Then we're going to put the side of the house, we'll call it 7. That is going to be a 5 by 10 as well. Interesting. So it's 10 by 5, which is the same as the other one, as well as the other wall of the house that we can't see, which will make 8, which is 10 by 5, which is 50. And now we come to a very interesting dilemma. Is the bottom of this particular one, which we will call face 9, is this something we need to calculate for surface area? The answer is it depends. It depends. If this is not a house that is going to be painted, but rather a, I don't know, like a thing that you hold in your hand, like a toy, and you're going to paint this toy house to give to somebody for Christmas, yes, you would probably paint the bottom. But if it was an actual house, probably not. So therefore, I'm pretty sure that this 9, which would be 6 by 10, is not going to be one we factor into our surface area. So assumptions on your test, sometimes they say you have to make that decision. Is this something that is factored in? Is it a paintable part? Is it a part of what my question may or may not be? If you did it, great. If you didn't, if you're like, I don't think that's part of the surface area, great. To calculate the surface area, you would add them all together. 100, 200, 260, 270, 280, 284. The total surface area would be 284 square meters. Moving along to your second homework question. This is a chocolate cake that has been put on top of another chocolate cake, and you're asked to calculate the surface area. So I'm going to make it a little bit easier to see because this is kind of hard to see in this board. Okay, just like that. We'll make it like that. Okay. And then we're going to make our little chart over here. Again, Lauren, if they did this for homework, great. You can just keep watching this video. If they did not attempt this yet, just get them to give this a go, give them the old Harvard try. They probably will complain. They've been really good at complaining about, this is so much work. Why are we doing this? This is stupid. It's Friday. Blah, blah, blah. Sorry, my imitation of my students is not very professional. I should be nicer. They are lovely people, though, Miss Fallen. They are very nice people. And sometimes the last couple of days I've been very frustrated and I haven't been very nice to them, so maybe I should apologize. I apologize for being impatient with you. You're wonderful people. With that said, let's put a 1 here. Okay, press pause, try it, we'll see how you do. I'm going to call it 1, you might call it something different. Okay, so 1 is a 25 by 5. Okay, and the back side, which we can't see that mirrors it, is also 25 by 5. And actually, the 3, which is on this side, is also 25 by 5. And the 4, which is on the other side that I can't see, is also a 25 by 5. Now, normally I would make the joke. I would ask Bryn, what number is that, or what is that? And she would say, why is it CL? And I'd say, it's not CL, it's 4. These are all 125. I'm beating that joke to death. Now, this is where it gets interesting. This is where it gets interesting. I'm going to put the circle here, and I'm going to put this, I'm going to call this one, what are we at, 5. And then I'm going to call the remainder of this, oh, sorry, not 5, I'm going to call it 6. Okay, I'm going to call that 6. Now, bear with me for a second. If you were looking at it from the top, it would look something like this if you're looking down at the cake. This would be where your 5 is, and this is straight down if you were a seagull flying over top of this cake. And what I want you to consider is that 5 and 6, regardless of what they are, is equal to the bottom of 7. Do you all see that? That 5 and 6 added together from a bird's eye's perspective in terms of icing volume would be equal to the icing on the bottom. Now, if somebody's just said in their head, but we're not icing the bottom of the cake. Good. Don't ice it. But what you do need to know is the dimensions of that cake are 25 by 25, which work out to be 625. Okay? And what I'm going to do is I don't care. I don't care. And I'm going to put in here that regardless of what the circle top is and regardless of what the 6 is, I don't care what they are individually. I know together they're going to be 625. And what I'm going to do, since this is about icing, I'm going to eliminate 7, the bottom of that cake, from being needed to icing. Okay? So now we have almost all of the sides of our cake iced. The only thing we're missing is this part of our cylinder, okay? And remember, this part of the cylinder is that tube shape, right, that goes around. And if we open it up, it actually becomes a rectangle, right? And the rectangle has the dimensions. The circumference of the rectangle is equal to this part here. The height of the cylinder is equal to this part here, okay? So if we can figure out those parts, we're off to the races. So this one is easy because it's right here. So in our rectangle for our face number 8, I better put 8 in here, that is 5 centimeters. Circumference is not given. Some might think that 20 there is the circumference, but you would be wrong. That is the diameter of the circle, not the circumference. So what we're actually going to say is the circumference is equal to pi times diameter. That's the formula. So what we're going to do is we're going to take pi, which is 3.14, and multiply it by the diameter, which is given of 20. And 3.14 times 20 is 62.8. So the circumference, which is this measurement, is 62.8. Okay? So if I was to just think of that side of that cylinder as the rectangle, it would be 62.8 centimeters long and 5 centimeters high, which means face 8, which has to be iced, is 62.8 by 5. Yes, that is 62.8. And if I take 62.8, multiply it by 5, it's 314, which is an interesting number. It's like pi without the decimal. Interesting. And therefore, if I'm asked what parts of the cake need to be iced, 250, 500, 1100, 1400, 1410, 1430, 1435, 1439. Therefore, 1,439 square centimeters of cake needs to be iced. Okay, that was your homework, the last two, plus the shelf question that I threw in for fun, and the steps question, which I'm sure you really enjoyed as well. The last question I just want to give you just right here. If you needed to calculate these on the provincial exam, sometimes what they say is these are 1 by 1. This is 1 centimeter. This is 1 centimeter, which would make this green square here, which would make that green square. I'll do it again. That square would have an end, so it's 1 by 1, which would be 1 square centimeter. Okay? So if it was 1 by 1, you would say, what's the surface area? You just count them. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And then on the side that I can't see, 37, 38, 39, 40, 41, 42. And the back side, which I can't see, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62. Therefore, this shape would have a surface area of 62 square centimeters. Now, tricky question. Sometimes they do it on the provincial exam because they're like, we're going to test the metal of our grade 9 brains. What if each of these cubes was not 1 by 1, but instead each of these cubes was 2 centimeters by 2 centimeters? Okay? How would that change the surface area? Well, now each of these faces is not 1. It's now 4 centimeters squared, right? So what effect does that have on this? Well, that would mean if it used to be 1 square centimeter, but now it's 4, we would then say if it's that, you would then multiply it by 4 to get 248, right? So if instead of being a 1 by 1 centimeter squared, each of those faces was 2 by 2, then the area of each of those faces is no longer 1 square centimeter, it's now 4 square centimeters, which means this is the 1 square centimeter face. If you multiply it by 4, you get the 4 square centimeter face, and it's that. And you can do it with this one as well, although I don't want to do it because it's too time consuming. I wanted to show it to you. Really quickly, going to this question, it says, what is the surface area of this shape? This is the one like the Cubalinx one where we took the corner out. If you remember, it does not affect the surface area, which is great. All we'd have to do, this is almost like the same one, it's 2 centimeters. Each of these distances here is 2. So if that's true, press pause, by the way, Lauren. We'll let them think this through. Let them see if they can do this. Okay, we're back. That distance there, that green line, if each of these distances between the dots is 2 centimeters, this is 2, 4, 6. This would be 6 centimeters long. It would be 1, 2, 4, 6, 8 centimeters high, right? So this face would be 48. The other side would also be 48, right? It would be a smaller part plus this one that's missing, but we know from our experience with the Cubalinx it's still going to be 48, which is great. And then the front would be 2, 4, 6, 8, 10 by 2, 4, 6, 8, 10 by 8, which is 80. So we'd have 2 80s. We'd have that in the back. And finally, the top would be 2, 4, 6, 8, 10, 12 by 2, 4, 6, 8. By the way, I'm doing the bottom. Or no, sorry, 6. The bottom 6. 2, 4, 6. So it's going, is that 12? It can't be 12. It must be 10. Did I do the mistake? Oh, I did a mistake. Which one did I make a mistake on? Huh. 2. Oh, okay, hang on. I think I made a mistake. 2, 4, 6, 8, 10. Oh, it's 12. Sugar cubes. It's 12 by 8, which is 96. Okay, my bad. And then the top would be, sorry, let's do that again. It's 12 this way. It's 6 this way. It's 72 on the top and 72 on the bottom. So therefore, we would simply have 48 times 2. That's this side and its counterpart on the other side. 96 times 2. That's this side and the one on the other side. And it would be 72 times 2, which would be the top and the bottom. And therefore, you'd have 96. You'd have 192. You'd have 144. Add those together. 100, 200, 330, 420, 430, 432 centimeters squared. I'm just exposing, you don't have to actually do this. I just want to show you that this is like that Cubalinx one. And to calculate it, just calculate the bottom to get the top. Don't worry about the other parts. And then finally, the last one. This is the very last one. What is the surface area of this? If you had to do it, and they were, let's say they were 2 each, so it's 2, 4, 6 by 2, 4, 6. This would be 36. This would be 36. The bottom would be 36. This one over here would be 36. This one over here would be 36. But this one's not 36. This front face, by the way, this 36 was the bottom. I was saying the bottom. This 36 was the back side. But this one here, if I was to draw it, there it is looking straight at it. It is still 6 by 6, but this distance here is 2, and this distance here is 2. So it's actually going to be 36 minus 4. This face would be 32. And then if you really wanted to get complicated, the inside part, if I was thinking about that little rectangle part, like this part here, that would be like if you were walking through the whole thing, it'd be like a rectangle. It would be 2 centimeters this way. It would be 6 this way. It would be 12. So with this other wall, so with the wall that we can't see, so with the wall on top. So there'd be 4 times 4, because there's 4 of those inside that would be counted as surface area, which would be 48. And therefore, this is complicated, I know. It's the end of the day on Friday. I know. We're done. So we have how many 36s? We have 36 times 4 of them. How many 32s do we have? That's this space here with the missing part. We have 2 of those. And how many of these 12s do we have that are the rectangles inside? We have 4 of those. So your total surface area is 72,144, 64, 48. It'd be 100, 200, 240, 248, 256. There you go. There you go. Hope that was okay. 38 minutes. You're all brain dead. Everyone's tired. Everyone's cranky. The substitute teacher's losing her mind. It's tough. Okay. Thank you all for being understanding. I will see you all on Monday.